Welcome. Today we're going to be learning about integers and graphing. So in this number routine, which is called today's number, with your tribe, you're going to tell me everything you know about positive and negative numbers. Well, positive and negative numbers could be represented on a number line. Positive numbers are such as 1, 2, 3, 4. While negative numbers have like a little minus sign in front of it, like -1, -2, -3, -4. Notice how that the negative numbers are counting backward, starting from 0, 0, -1, -2, -3, -4. What else can you say? It could be like examples. I found money. That's a positive. I spent money. That's a negative. The airplane went 4,000 up, flew so 4,000 feet above the land. So that'd be positive. A submarine is below the sea level. So those are examples. So last night you brainstormed everything you know about positive and negative numbers. So first of all, the first thing I want you to do is I would like you to fill in the blank integers. We're going to fill in the blank integers right here. So we have 0. There must be a faster way of writing. We have 0. We have 1. We have 2. We have 3. We have -1, -2, -3, -4, -5, and let's do 4 and 5 right here. So those are examples. All right. All right, you know what? Let's go back and use, those are visible ink. 0, 1, 2, 3, 4, 5. And not sure why I use red because then you're not going to be able to see it. So I'll use green, -1, -2, -3, -4, -5. Notice how the positive numbers are to the right of 0, while the negative numbers are to the left of 0. So next thing. What is the opposite of 4? How do you know? Show me. Well, here I see 4 right here. This is 4. What is on the opposite side? It's the same distance. Well, here's 4. It's 4 spaces from 0. 1, 2, 3, 4. -4 is 1, 2, 3, 4. So the opposite of 4 is -4. Some people say, what's the opposite of positive? If you're positive all day, smiling is a negative person who's frowning all day. So opposite of positive is negative, opposite of negative is positive. But let's do a mathematical definition. It is the number of spaces or number of units from 0 on the opposite side. So show me. So I see there's 4 units from 0. -4 also has 4 units from 0. What is the opposite of -5? Here's -5 right here. I think it's 5. How do you know? Show me. -5 is 5 units from 0, while 5 is 5 units from 0. So -5 and 5 are opposites. What is the opposite of 0? 0. Opposite of 0 is 0. Because if you look closely on the 0, is neither positive nor negative. 0 is 0 spaces from 0. So 0. Integers are whole numbers and their opposite. Whole numbers are numbers such as 0, 1, 2, 3, 4, 5. You've learned whole numbers since you've first grade, second grade, and its opposite, which is sixth grade. What's the opposite of 1? -1, -2, -3, -4, -5. Some people say integers are positive or negative, and it's like whole numbers and their opposite. And our last one, I would like you to locate 1.5. So I'm going to locate 1.5 or 1.5 right here. Is it an integer? No. It's a decimal. Could be a fraction, 1.5. Why or why not? Because an integer are whole numbers such as 1, 2. 1 and 2 are integers, but 1.5 is not. So what we're going to do is I'm going to be passing out sticky notes to different students in the class. If you were given a sticky note, you'll write your first name and place the note in the most appropriate circle of the Venn diagram. Which label best describes you? For example, I call a student named Jeff. Jeff is a boy sitting in my class. He's wearing a white shirt and Nike pants. So would he describe himself as a girl wearing blue shirt, a girl, or a student? Just a student. I call another student, Mallory. Mallory is wearing all red. Is she a student? Yes. So could Mallory put her name right here in the outer circle? Is there a better description of her? What about a girl? What about a girl wearing blue shirt? No, because she's wearing all red. Next, I call another student named Jane. Jane is wearing a blue shirt and blue jeans. Is Jane a, so she could be here in this inner circle. Could she be a girl? Yes. So she could be out here too. Is she a student? Yes. But what is her best description? How would you best describe Jane? A girl who's wearing a blue shirt. How does that relate to mathematics? Well, there are three types of number: whole numbers, integers, and rational numbers. Let's look at our first one. What number belong in the whole numbers section? Can you tell me some whole numbers? Think of your number line. 0 is a whole number. 5 is a whole number. 6 is a whole number. 8 is a whole number. What about 1? Yep. What about 11? 11 is a whole number. Notice that all of these, what do they all have in common? What can you tell me what they all have in common? They're all positive. And do you see any decimals? Nope. They're all positive. That's what they all have in common. Next one. Give examples of integers now. I would like you to give me some examples of integers. Integers are whole numbers such as 1, 0, 1, 5, 6, 8, 11, and their opposite. So could I put the number 4 right here in integers? I could, but isn't 4 better represented as a whole number? So its opposite is -4. 1 is a whole number, opposite is -1. 8, opposite is -8. 5, 5 units from 0. -5 is 5 units from 0. 6, -6. 0, actually 0, it can be best represented as a whole number. So our next thing I would like to talk about, take it away. Rational numbers are numbers that can be written as fraction, like in fraction form. So can you think of some rational numbers, some examples of rational numbers? Like 1/2, 3/4. What about, let me erase this. What about 5/10? Yeah. So rational numbers are numbers that can be written as fractions. Can decimal be rational numbers? Can decimal be written in fraction form? Let's think of this: 5/10. 5/10. Is that the same as saying this fraction 5/10? Isn't 5/10 could be simplified to 1/2? Yes. What about 4/10? In fraction form, it could be 4/10 or 2/5. That's simplified. And our last example, so give me examples of rational numbers, and we did so. So what you're going to do now is you're going to be getting, I would pass out 12 numbers throughout the class, and you are going to put them in the correct bag. Why did you, oh, before we do that, so let's put numbers in the bag. So let me use my finger. 2. 2 is a whole number. -1 integer. 1 point, let's do a whole number first. It's easier. 8 whole number. 1 whole number. 0, whoops, 0 whole number. 5 whole numbers. Let's look at this one closely. Some people say that this is a fraction. Do you remember something called improper fraction last year? What's 15 divided by 5? 3. That's a whole number. Integer are whole numbers, and we already did all the whole numbers, and it's opposite. So again, if you look at this bag, an integer could be, it's everything in this circle. It's everything inside the circle that includes integers and whole numbers. So integers are whole numbers, all these whole numbers, and is opposite, like -1. We have 8 and -8. We have 4 and -4. And then rational number, any numbers that we've written in fraction form, 2/3, 1/2, 4 and 5/10, 1 and 5/10, -3 and 25/100ths, and this is actually 1/3. So our question is, why did you classify 1 and 5/10 as a rational number instead of integer? Because integer are whole numbers and it's opposite. And this can be written in fraction. And if a number fits into all three categories, let's say all three categories, where is it placed? Why? It could be, let's use the example of this one right here. This could be a rational number because it is written in fraction form, and it could be a whole number because it's 3. And could it be an integer? Yes, because the whole number opposite. So it'll be located in whole numbers. Whole numbers can be integers, and whole numbers can be written in fraction. So what we're going to do now is we're going to look at your notes. You have written notes, so it helps solidify your thinking. Whole numbers are simply the numbers 0, 1, 2, 3, 4, 5, and so on. Notice there are no fractions. It's all positive. And next part, integers are like whole numbers, but they also include negative numbers, the opposite, but still no fractions and decimals are allowed. So integers can be negative, like -3, -2, -1, positive, 1, 2, 3, or 0. And rational numbers are numbers that be written as fractions or decimals. So can you, on your own, think of numbers that fit into here? So can you think of some whole numbers on your own? Label some whole numbers. Brainstorm. 4 and 7. Give me some integers. I could say 4, but it's better to describe it as a whole number. So what, -4? I could say 7, but 7 is better described as a whole number. -7, -3, -5. Well, where would 0 go? 0 is best represented as a whole number, but it could be integer. And last but not least, give me some rational numbers. Rational numbers are anything that we written in fraction or decimal, like 2/3, 4/5. Could 0 divided, could this 8, the improper, what about the improper fraction of 8/2? That is fraction, that is a rational number, but could it be a whole number? That could be 4. So best represented here, or it could be an integer. And last activity is, last feeding. In here, can you tell me which number is in the wrong spot? What's in the wrong spot? Let's look closely. Anything in here, do you notice that they're in the wrong spot? I see 3 and 5/10, rational number, wrong spot. Is the whole number supposed to be positive? Wrong spot. Wrong spot. 3/4. 6 is a whole number. 14 is a whole number. And that we're done now. So, which number line should you use? Horizontal or vertical? It really doesn't matter. It depends on the scenario. So we have 4 scenarios right here. If someone says, I withdrew or withdraw $5, what does that mean to you? It means I took out $4 to $5. Is that negative or positive? That's a negative. So how would you represent that? -5. So you put a dot right here at -$5. If someone says, I earned $5, what does that mean to you? Earned $5. That means it's right here. Positive, meaning I have money. If someone says, by the way, these are opposite each other. If someone says 3 feet below the sea, what does that mean to you? 3 feet below the sea. That's if sea level is 0, below means -3. So it could be either this number line, the vertical, or the horizontal number line. If someone said I deposit $4, what does that mean to you? I'm putting money in the bank, so deposit $4. Last but not least, you're going to be given some real life, real world situations such as deposit $5 and withdraw $2. How would you represent this on a number line on your own? So in this one, it was already drawn for you. Can you now represent it yourself? So let's get my pen. Do you want to put 0 in the center? You can if you want to. Do you have to? Not really. I'm going to put 0 right here. What numbers go to the right of it? What integers go to the right of it? Positive. When you count backward, a negative is -1, -2, -3. So deposit $5. What does that mean to you when I deposit $5? Means I'm putting money in bank, so it's positive. So right here. Now withdraw $2. Withdraw $2. So I'll put 0 right here. -1, -2, 1, 2, 3. Positive integers to the right of it. Negative integers to the left of 0. Withdraw $2 means I'm taking money out of the bank, so -2 right here. And now how would you put it on a griddable? -$2. Let's think. How would you write say $2, -$2 as a decimal? -2.00. So you bubble in the negative, you bubble in the 2. If you want to bubble in the zeros like this, you may. You do not have to. Usually in middle school and high school, we don't usually do that. We just bubble in the negative and the 2. And our last example before we go is, let's see if you understood the lesson. The submarine is 24 kilometers below the sea level. Represent this situation as an integer. How would you write it's below sea level? Well, if sea level is 0, the sea level is 0, below it is negative, so it must be negative. So bubble in negative. If I put the digits 2 and 4 behind it, that'll be 0.20. Nope, it goes in front of it. -24. And that is our lesson over integers and graphing.